Hey everyone, welcome to this Blockchain Explainer video. This is Frederick Munawa from Blockchain Innovation Academy, and in this lesson, we will cover 8 specific things. We'll cover Bitcoin and blockchain, what a blockchain is, the journey of a Bitcoin transaction, Sybil resistance and proof of work, blockchain consensus, private versus public blockchains, challenges blockchains face, and blockchain use cases. This will be simple and straightforward, so sit back, relax, and let's dive right in. Okay, so first, Bitcoin. Bitcoin is not the same thing as blockchain. Bitcoin is the world's first peer-to-peer digital currency. It was created by Satoshi Nakamoto and launched in January of 2009, and you can send Bitcoin directly to someone else without going through a financial institution or other third party. Now, Satoshi Nakamoto is most likely a pseudonym. That means it's probably a made up name. We don't really know who Satoshi is. It may even be a group of people. Now, blockchain is the technology that powers Bitcoin. So essentially, Satoshi created both Bitcoin and blockchain, and Bitcoin is the first and still the most successful application of blockchain, at least at the time of this recording. So, what is a blockchain? Well, a blockchain is a data structure. It is a collection of data in a specific layout. And that layout consists of blocks of data chained together, a chain of blocks. In fact, that is the exact term Satoshi used when he wrote the Bitcoin white paper. Of course, nowadays we have many different types of blockchains, but in this video, to keep things simple, I'll only describe how the Bitcoin blockchain works. Okay, so a blockchain is a data structure. It's a chain of blocks, but what's in each block? Well, there are several elements in a block, but since we're keeping things simple, just keep these 3 items in mind. First, a block will have a list of transactions. On the Bitcoin blockchain, for example, this would be a collection of Bitcoin transactions. Second, a block will have a timestamp, so we know when the block was created. Third, a block will have a hash of the previous block. And what's a hash? Well, a hash is the output of a cryptographic hash algorithm. Think of it as a unique ID number, but it's a special type of ID number because it is mathematically tied to the contents of the block it represents. In other words, if any malicious actor attempts to make even the smallest change in a block, the algorithm picks it up. And since every block contains the ID number of the previous block, that ID number or hash acts as a chain that links a block to the one before it, all the way to the very first block, also called the Genesis block. And that's how the blockchain secures the integrity of its data. So now we have this chain of blocks, a blockchain, that contains transactional data. Where is this blockchain located? Well, that's part of the magic. You may have heard people using the term decentralized or distributed ledger. That's because blockchains run on networks that are distributed all over the world, and each computer on that distributed network has an identical copy of the blockchain. And since everyone has an identical copy of the blockchain, it becomes extremely difficult to cheat by spending money that you don't have or spending the same money twice, something known as double spending. In other words, everyone has a single shared version of the truth. And it is also very difficult to cheat or tamper with past transactions because all of the blocks are linked together and significant computational effort is required to make any changes to the blockchain, as we'll see when we discuss something called proof of work in a few seconds here. Okay, let's take a look at the journey of a Bitcoin transaction. In fact, let's see what happens to a Bitcoin when it's sent from one person to another. When you send a Bitcoin, computers on the Bitcoin network called miners or mining nodes take your transaction and include it in a block. Bitcoin is a public blockchain that anyone can use or join. So the Bitcoin network has literally thousands of mining nodes spread out across the globe. But remember, we need a single shared version of the truth. That means only one mining node out of thousands is allowed to add the new block that contains your transaction onto the blockchain. And exactly how does the network decide Which node gets to add the new block? Well, via a lottery system called proof of work. Each mining node competes to solve a difficult mathematical problem, and the first node to produce the correct solution gets to add the new block onto the chain. On the Bitcoin network, this happens approximately every 10 minutes. That mining node also receives a few Bitcoins for solving the problem, which is why mining has become a very lucrative and fiercely competitive activity. By the way, this is the same concept, referred to as Sybil resistance, that is used to prevent spam. In fact, proof of work was originally designed in 1992 for that very purpose, combating junk mail. Fun fact, Sybil is the name of a character with multiple personalities from a 1973 novel, so that's where the term Sybil resistance comes from. Okay, so now we have a chain of blocks all linked together by hashes, with miners adding a new block every 10 minutes or so. What happens when two different blocks are added at the exact same time? Meaning you no longer have a single shared version of the truth. In other words, the chain splits or forks into two chains. Well, on the Bitcoin network, nodes are designed to always follow the chain where most of the computational effort has been invested. Remember the proof of work lottery system we discussed earlier? That's the computational effort we are referring to here. And that's the metric the network uses to reach a consensus on which chain to follow. Now, so far, I've been using Bitcoin to illustrate how a blockchain works. Bitcoin is a public blockchain, meaning anyone can view or use it. There are other blockchains that require permission to view or use them, and these are called private blockchains. Many of the key features of blockchains are lost when a private chain is created, but there are circumstances where a private chain is the best solution. So I hope that helps you see the difference between private and public blockchains. Now, what are some of the benefits of blockchain? One big benefit is disintermediation. Disintermediation is the removal of third parties, intermediaries, or central authorities. And blockchains facilitate peer-to-peer transactions. For example, I no longer need PayPal or Western Union to send or receive money. With something like Bitcoin, I can send money directly, so peer-to-peer, almost instantly, anywhere, anytime. Another benefit is trust. Since a public blockchain isn't controlled by a central authority, we don't have to trust a government or a company. Instead, we have thousands of independent nodes in a decentralized peer-to-peer network governed by algorithms and cryptography. In other words, trust is built right into the system, and as we discussed before, everyone has a single shared copy of the truth. Then we have decentralization. A decentralized network means there is no central server to hack. The security from robust Sybil resistance and consensus mechanisms, which we discussed earlier, is extremely difficult to compromise. And lastly, censorship resistance. Traditional systems with central authorities like banks and other financial institutions can easily reverse transactions, and they decide who gets to use their services. Now, this may be due to regulation or a bank's risk profile, for example. But public blockchains like Bitcoin allow anyone to transact anywhere, anytime, on equal terms, and that's called censorship resistance. Now, let's take a look at some of the challenges blockchains face. One big challenge involves speed, scalability, and capacity. As of this recording, about 4 billion people worldwide use the internet. Now, if billions of people and large corporations were to start using public blockchains like Bitcoin on a massive scale, would those blockchains be able to evolve quickly enough to deal with that kind of volume and demand? Another challenge is privacy. Many public blockchains make transaction details available to any and everyone. That standard of privacy may not suit certain use cases, especially those involving regulated financial institutions. Now, I must clarify, personal details like names, contact information, and other sensitive details are neither required nor stored on the Bitcoin blockchain. Only very basic transaction details are stored on the Bitcoin blockchain. Now, a third challenge for blockchains is regulatory uncertainty. Cryptocurrencies and tokens have had to deal with several legal and regulatory hurdles. For example, Bitcoin has been banned, or at least has had its usage restricted in several countries. Some blockchain tokens used for crowdfunding have been identified as securities, which has led to all kinds of legal issues, and only time will tell how some of these issues will eventually play out. And finally, another challenge is governance. Now, governance is about making decisions, and this is relatively easy to do with traditional systems that have a central authority to make those decisions. Now, to be clear, we're not talking about algorithmic consensus here, which we discussed earlier, but rather governance of the system itself. With many decentralized blockchains, decisions about making changes to the system have been difficult to make and sometimes even polarizing. An example is the Bitcoin block size debate that eventually led to the first major split of the Bitcoin blockchain. Okay, so those are some of the challenges. Now, before we conclude this lesson, here's a quick list of current blockchain use cases. We've already discussed cryptocurrencies and tokens, but you also have supply chains, you have the ability to tokenize real-world assets, and you have digital identity and many other use cases as well. And we do have separate videos going over these other use cases. Okay, now let's recap everything. Now you know the difference between Bitcoin and blockchain. You understand what a blockchain is, the journey of a Bitcoin transaction, Sybil resistance and proof of work, blockchain consensus, private versus public blockchains, challenges blockchains face, and you're familiar with blockchain use cases. Now, if you want to learn more about blockchain, subscribe to my podcast at blockchain.global. Thank you for watching.